Give it a moment. We're going to need to turn this front light off. Let me see. I think that might be this. Is this one? All right. Is that good enough? People in the back see that? Yeah? I'll make it a little larger too. All right. I'm not going to sit down for this part. Well, I guess I have the lesson plan up here, but also anyone who's online can chime in on this. Before we get started going over anything for today, let's just see maybe a quick show of hands who at least started on what I sent out for the lesson 3 homework. All right. Was anybody able to finish all of it? No, that's pretty good. Pretty good. All right. Anybody have some problems with some of it? Any challenges? Something that they couldn't get through? Okay. Yeah.
And then I would just take my code and put it over the check it, especially like the
right.
And so I'm not sure, and then when you guys before it needs to be in I'm not sure I don't know.
Okay. Were you getting any errors?
Yeah, as process exiting the code 0. And it's have a circular like keeps turning or the access is trying to run.
All right, good. So you know the answer?
I know the answer. We were going through that earlier. So after she went away to her business, then I was messing with mine. If you hit play on the top, then it'll create a new batch on the bottom terminal, and it'll go back.
Yes, I did. I hit on the top, and it created a new file on the bottom, and then it just.
You save as the file? Environment.js?
Yeah, it's saved. Well, I just do save.
You can save as, or you just do a reader as. So you make .js and you make the wrong button.
Well, I did, and I fixed it.
All right. Well, if there's any specific hands-on things, there'll probably be some time at the end of class. If not, then when we take our usual break, where we take like a 5-minute break at about the hour mark, I should have some time where I can hopefully come take a look and work through what's going on. Anybody have problems with any of the actual exercises? Yes.
I'm a little confused with the logic section. Like what exactly were we? I think I got confused when you said output whether the above statement is true or false. Like were you looking for us to get it to tell us if it was false or true? Yeah.
All right. Let me.
Yeah.
This section here.
Yeah, I was just confused about what the goal was.
Yeah, the goal there was, I mean, I'll go ahead and just copy this into, I'll use a Scratch file to do some of this stuff. Probably could have been a little more clear, but the general goal there was just to get practice writing some, no, this is, I need to change this. This should not be markdown.
We're just trying them into statements.
Let me close this. I don't want to scratch markdown. I want to scratch JavaScript file. Different one. Don't save that. Let me create another one. All right, scratch.js. Yeah, the goal was to just get some practice writing if statements. So it shouldn't be that complicated. If you're familiar with it, it might be something like, let me read the first one. Output whether the above statement is true or false. So the goal was to do something like this. If E, or you could even do it a different way if you want. So you could do it like this. Var value equals E is greater than pi. And then you could just output like the value. So you didn't have to necessarily even do an if statement. In that case, so So if I run that, we should get the result. But you could also have done it with some if statement inside of an if statement, where it's if e is greater than pi, console.log true or something, right?
That's what I did.
So yeah, the goal was just to get some practice writing just conditional statements and how you can use them in your code. Anybody have problems with another section of it? No? All right. We'll get moving into lesson 4 then. And lesson 4, is that large enough for people? Everyone can see it? All right. So today, we're going to do a review again. It'll go pretty quickly. And then we're going to talk about a couple new types. We're going to build on if statements a little bit more, some of this conditional logic, and then we're going to get into looping. So the general concept for today's class is talking about control flow, or how do you control the flow of your program. So just a quick review. Does anybody remember what type coercion is and where it happens in a JavaScript file? Anybody want to? It's a little bit of a weird phrase, so it might be tricky. Yeah?
Is it where you take variables, I guess, and connect them onto a string?
That's concatenation, which is close. Coercion is where the JavaScript actually converts a variable of one type to another type for the purpose of performing some operation. So an example of that, if we have our basic read about print loop, is if we compared 42, the number, to the string 42 using the double equals, it coerces the string 42 to a number, or the number 42 to a string, and you get true out of that, even though they're different types. So they're not actually the same value. And does anybody remember what the 2 operators are that we use for comparison that don't do type coercion? Triple? Yeah, triple equals. So if we rewrote this and we put a triple equals, the answer is false. And that's because it's not only comparing. Do you guys need that drawn up on the screen a little bit, or is that visible to everyone? Let me pull it up some. And that's because not only is it comparing the course values now, it's also comparing the type. So it's saying a number is not equal to a string. It doesn't even matter what those values are. A number can't be equal to a string if they're different types when you're doing a non-coercive comparison. Does it make sense? Yeah? All right. Then we've got all of our Boolean operators that we talked about. We've got our comparison ones, where we've got the double equals, which is the coercion comparison, triple equals, which doesn't do type coercion, less than or equal to, greater than or equal to, not equal, and not equal without type coercion. Everybody clear on the different Boolean operators? We good on those? Any questions? Feel free to ask if you do. What about the logical operators? Anybody want to tell me what these 3 logical operators are, if you can remember them? And, or, and not? Yep. And you should have had some stuff working, or some of your homework should have had you work with some of that a little bit. Any of that trip you up at all? It tripped you up? All right. Is there anything specific, like one of the problems? All right. Yeah, good to know. Oh, exactly. Yeah, yeah. I will I mean, definitely hit me up individually on Slack, just to make sure that you're not getting lost on any of that if anybody else is having those problems. Or just post something in the group chat as well, especially if there's something that's just giving you any sort of challenge, you know? Copy a bit of code in there to say, this isn't doing what I thought it should do. Why isn't it working that way? Our Slack channel should be definitely more active than I'm seeing so far in terms of just asking questions and saying what's going on here. So, but again, there'll probably be a little bit of time at the end of class. If you have any questions and you want to sit down and go through some of that, we're going to continue to work with some of that some more today. So it might help bring a little bit more clarity, but just let me know. All right. Anyone else hung up on any of the logical operators at all? Yes.
You had like the main age, like not age. So if you had set the age was 25, so not 25 makes that false, but if you said not 0, they said that was true. And I was confused like they're kind of thing.
Let me try and pull it up real fast. This is in this more logic area?
Yes.
Yeah.
So we have like and then not age, not 0. I was trying to like kind of figure out.
Yeah. I'm glad you're bringing that up because some of that was intentional, where I expected some of this to be a little confusing and to cause some issues. So I'm going to pull it over here and we'll walk through these different statements. Yeah, you know what? It's going to be easier to do this in the read eval print loop where I've defined them, because then I don't have to do console logs around each one of them. So I'm going to grab all this and then we'll run each one of those statements individually. So I'm already in it. Oh, there we go. Okay, so now I've defined all those variables, and we can walk through each one of these collectively. We'll just do that, and then we're going to do some more of this hands-on immediately at the start of this class, where we'll work through some more complex logic bits. And I was actively trying to find a nice interactive quiz that I could have you guys do it with. I didn't find anything that I liked. I'm still looking for something that's really going to capture the ability to have you guys first do a quiz by yourself and then split up into groups, talk about it, and do it again. But we're going to simulate that without the quiz with some of the initial items for today. So let's work through this. If we have these statements already defined, and I'll try and, I can't, yeah, I guess it shows all of it right now. So if we have all these variables that you see up above defined, what do we expect this first statement to evaluate to? Oops, having a hard time capturing just the line. There we go. It's going to be false. That's because age it's doing these comparisons in the order of operation, and age is greater than 10 is true. So the first part is true, but age is less than 20 is false. Since it's an and, one side of it's false, right? That one's the pretty easy one. Now, which one were you? Not age. Like, okay, like line 15 here, 16. Yeah, these are good ones. So this is another example of type coercion, where when you put something that is not a Boolean through this Boolean logical operator of not, it treats it as a truthy or a falsy value. And you remember we talked about the concept of truthy and falsy in the last class, where only, I'm going to get the list a little off, but 0, an empty string, null, undefined, and I think there's one other case.
Space, right? Like space.
No, a space I think is truthy. Let's check that. I think we can check that. So that should say that it's true, and that's because it was falsy. If you want to really see, you can put 2 nots because you're negating twice. So the first one is converting to a Boolean, and the next one is converting it to the opposite, which would have been the equivalent. But if we put an actual space there, that's true. So it's only empty string. Any other value in your string is going to be truthy. And that's what's happening here. So when you do like not age, it's essentially checking, it's saying is 25 truthy or falsy. 25 is truthy because it's not 0. And so the not of that is false. And it converts it to an actual Boolean. And then the not 0, let me double check what the values are. 0 is the actual number 0. So since we know that that's falsy as a value, not falsy should give us true, which is what we get out. But 0 string is not the number, it's a string. And we already saw that the space, for example, gave us a value that was truthy. So if I do 0 string, not of it, it's false, and that's because it's a string that isn't the empty string, so it's actually truthy. So it doesn't convert it to a number first of 0 and then check whether it's truthy or falsy. It checks the string as a whole and whether it's truthy or falsy. Does that make some sense? You're like, yeah, it's still confusing. Yeah, I mean, some of that stuff you just get used to working with it a little bit. I'll try and put some other items in the next assignment that have to do with truthy and falsy to help reinforce some of that or get you thinking about it some more. Yeah.
I just want to confirm, I think the dot length part of the homework, it counts the letters for the word at dot length.
Yeah, that was the part that nobody brought up, right? Is that's something that we haven't encountered before yet in class. So who did this and who had their guess correct as to how the code was going to work? All right, and who was wrong? Nobody wants to admit that. I would have been wrong. I don't know. I don't think there's anything wrong with being wrong when you're taking a guess at how code works. I think it's just a really useful practice to get into, which is, okay, I'm going to write a bit of code. I think I know what it's going to do. Let me run it and check that. And then help learn from that. So you're correct. Strings actually have some properties on them that you can get off of them. In fact, once you have an actual variable, pretty much every variable has certain properties that you can get out of it. So for example, we have this 0 variable, which is a number, and we've seen that before. But because I have it in this variable now, I can actually do toString. And what I get out of that, if I take that same line and I check what the type is that I got from this, I got back a string. So basically it converted the number to a string. And we'll get into exactly what that is as we get, probably next week, I'm guessing, is where we'll get into talking about functions. May not get the methods yet then, but this is just an operation that you can perform on it. And strings, the same way, have some properties on them, and one of them is length, and that tells you how long is this string. So if you do dot length on any string, you'll get back the length of the string. Yes? What's that?
Is that it counts spaces.
Yes, it will count spaces. It counts any character in the string. So did I have, oh yeah, the name, right? In this case, has a space in it, and that might be tricky to somebody as they may think that that's not the case, but it's going to count every character in this, including the space. So you can see that we get back 9 when we check that one. Yes?
If you run that code, you won't get it.
Yeah, that's right. Yep. I mean, there were a couple tricky things in there. I introduced this new concept of length, and then I intentionally had the if statement not do what you would expect it to do. right? That's where I definitely would have made the mistake of doing this wrong, because I would have looked at this, thought somebody was giving me something straightforward, and then gone, they tricked me. Dang it, right? And that's not an accident. The intention is to learn to read the code carefully when you're trying to figure out what something does.
There's no else.
Yep. And that's what we're going to get into today. We're going to start talking about else statements in just a minute. It only lets me have one of these previews open, I guess. So, yes. I really would like to find a nice way to submit those as well, but until we've done probably most of a class devoted to Git or something like it, there's not an easy way for people to create them and post them. And so the traditional model has been sort of just, you know, be honest about whether you're working on this stuff and try and do it. This isn't, you know, a college classroom or a high school classroom. This is definitely a setting where if you want to put the work in, you're going to get the value out. And if you think like, oh, I'm going to get by without doing this work, you're not going to really grab the material. So there's a little bit of up to you, but I would like to try and get some tooling in place to make it easier for people to submit some of that stuff. That's one of the reasons that I will be introducing the Replit or REPL.it site, where I can actually see how people do on the work. Plus it helps give feedback on any problems that I see them encountering. Yes. Yeah, the first thing I would say, again, is let's lean on our peers, right? If you're interested in that, I'll be happy to post answers. It wouldn't be very hard for me to post answers, but I think it would be probably even more beneficial for somebody to say, hey, I'm really wondering how other people solve this homework problem. Do we want to go ahead and post what your code was in Slack or something, right? And that may provide some insights into how different people are solving the problems. I can. Well, part of it is, and I'll admit, I'll post something for them if that's what you guys want. I have no problem doing that. I don't want to necessarily force people to think this exact same way that I think in terms of solving the problem, because on a lot of these, there's different ways to write them out. And if their solution, if the way somebody else wrote it solves the problem and gets the correct answer, then I don't want somebody to look at that and then look at code that I wrote and say, oh, I didn't solve this the right way. I should have written it this other way. That's not necessarily true, right? I wanted to give people the opportunity to, oh, no, it's just a different way to have solved this same problem, right? So I definitely want to at least leave a time lapse if I'm going to go ahead and post the answers to stuff before I post them, so that people have the opportunity to work through them and try and have their own solutions. Good conversation on that. Appreciate you talking up about that. It's really, really useful to know that that's something that you guys really want to see. So, and then the last thing that we talked about last class, where we started talking about if statements. And that's just a way for us to, that was our first real program control flow, or control flow at all, that we've introduced. And that's the ability to decide whether you'll conditionally run some code based off of a Boolean evaluation of some bit of expression. The if statements, as a basic concept, pretty clear? Yeah? I think they're a lot easier to understand than some of the other stuff that we've talked about. So I'm going to introduce today we'll talk about a couple things that are a little confusing, and one of them is really sort of unique to JavaScript. I almost apologize that it's got this extra bit of confusion that other programming languages don't have. And those are two new types. That's null and undefined. Then we're going to get into do a quick review of block statements, just at a little deeper level than we talked about with the if stuff. I sort of glossed over it as I introduced it with if. We'll go into more if statements, working through some of those, including some of the additional options that exist to help some of that control flow. And then we'll get into doing looping, which is another conditional control flow with, so that you can just execute code in a different path. Oh, those are not the exercises for right now. So let's start off again with just some class-based interaction. Let's take, I don't know, about 30 seconds or so. You can talk with somebody if you want. And for each one of these, let me bring this up, make it more narrow so that you guys are sort of only seeing one at a time. I want you to try and figure out what you think is going to be output by this program. And so if you're, feel free to talk with people. I encourage you to, so that, oh, I'm not sure what's going to happen in this portion of it. And I wish it would stay there. When you think you've settled on something, go ahead and throw your hand up so I can see some hands start to go up. And if you're watching this remotely, go ahead and post something in Slack if you want. I would love to have those answers in there as well. All right. Seen a good number of hands go up. What do we have for guesses? 4 days? Okay. Let's go ahead and we'll step out of this and we'll run the program and we'll see what we get. Sure enough, we get 4 days. And it's, breaking it down, since this is in parentheses, it does number-based addition here first, adding 1 and 3 and getting 4. Then we're adding that to a string and adding that to another string. So at that point, it now converts that number or coerces it into a string and does string concatenation to get out the result 4 days. So let's go with another one. I'll just go ahead and I think this will work just fine. You have this, and once people can talk again if you want, but once you think you have the answer for this one, go ahead, shoot your hand up. $12? False. All right. Seeing some hands, seeing some hands. All right, what do we think we have? Oh. Ah, all right, all right. I've heard some disagreement here. This is good. All right, we're false. Anybody who had true? Anyone want to say? All right. Let's break it down again and just see what we get to. This process, when you're learning how to read code, this is a really useful practice. So we have 10, and we do 10 plus 1. So this is now 11. Now let's step over here. We've got 11. 11 minus 1 is 10. So is 11 less than or equal to 10? That's false, so we get false out. And the interesting thing there is, again, we get false out because it actually coerced or converted that Boolean of false into a string to give us false when it printed it. So let's grab, let me see how many more I have. I got 2 more. So let's take a try at this one. When you think you have the answer, go ahead and throw your hand up. All right. Seeing a lot of hands. What do we got? Oh, let's just the up arrow. Ah, see, it does both parts, right? So one thing you may have missed there is the second console log down below. And one more. All right. There we go. Hearing a good number of people with an answer. All right. What do we got? Just the second one? That's all we get. And the only difference between this and the last program was that we're using the non-coercive version of comparison as opposed to the coercive one. So the number 42 is not equal to the string 42. All right, that was just some more review, but I wanted to do some hands-on stuff in class and have you guys talk with each other, because I find that it helps a lot when you're having that conversation. You'll be like, oh, I missed this part of it. Oh yeah, I totally get what you're saying now. It's a lot easier to pick up stuff from your peers than it is just from the instructor up here. Yes?
I have a question, like here when it's not equal to 42, the number, like as in like a triple equal.
Yes.
So the statement is false, right?
Yes.
But it chose to ignore, there is no else statement here. So it chose not to do anything. But like what I think, shouldn't you get an error because it's just not equal?
Nope.
It doesn't. What is it supposed to do? How does it know that it's supposed to ignore?
It just,
it's wrong.
all it knows is to run this bit of code if it says basically what's going on here, and I'll talk a little bit more about what this block statement's doing, but all an if statement's doing is saying, if whatever I give this is truthy, run the next statement. Otherwise, don't run the next statement.
It just depends on the context. Like when you're writing a program, the logic will just depend on whether or not you want to have a block as well. Like sometimes you just want this, or you want something if it's true. And in other circumstances, you might want it to do something if it's true, and then you might want to do something false. So it just completely depends on the context.
Yep. All right, are we ready to move on? Let's talk about nothing. All right. So JavaScript is even worse than most programming languages, and that's saying something because most of them are pretty bad when it comes to nothing, because JavaScript has two different types that actually mean nothing in it. It has undefined, which means a variable has been declared but not yet assigned a value. And we've seen that, right? If we have var foo, and then we do type of foo, it's undefined. That's what we get back. And that just means that this hasn't been assigned a value. There's nothing in it yet. It's undefined. But then there's also a second value, a second type that means nothing, and that's null. Null is pretty common in programming languages. There are some languages that don't have the concept of null, but most of them have the concept of it in some way or another. Some of them might call it nil instead of null, if you've ever seen, say, Ruby. And null is actually an assigned value that represents nothing. It's distinct from, say, the value 0 for a number or an empty string. So if I have foo and I can assign it null, and that's actually the value of foo now, is this special type null. And that means it just is there to represent nothing. So let's go ahead and we'll move through this a little bit faster, but people want to throw out guesses as to what the result of each one of these evaluations is going to be when we run it. What do you think about foo? Oh, hold on. I need to clean foo up. I need to use a different variable here. So let me just exit my REPL and open a new one so I have a fresh foo. So this matches. We are already seeing this is going to be undefined. So now what do you think foo triple equals undefined is going to return? True? True. Because it matches the same type, right? That's a type specific one. So now I'm going to define another variable, bar, and I'm going to explicitly assign it null. And just in case you're wondering, foo and bar, those are just sort of canonical programming language variable names. I don't know where they originally came from. What? Yes, but we've changed the casing or the spelling of it, so it's not inappropriate. So what do you think the type of bar is going to be after I told you it was its own type? What? False? Type of? No? We're going to skip that for the moment. Ignore that. We're going to come back to it. All right? All right? What about bar triple equals null? True? All right? Maybe I'll have people, I think all these are truthy or falsy, so I might just do a quick poll like true or false for people. And true? All right? What about undefined triple equals undefined? Who thinks it's true? All right, who thinks it's false? Right? That's true. It's the same type, same value. What about null triple equals null? Who thinks it's true? All right, anyone think it's false? It's true. I know you're looking for a gotcha, right? All right, what about null triple equals undefined? We think it's false, most people? False? Who thinks it's true? You're gonna say true? It's false. What about null double equals undefined? Who thinks it's true? Who thinks it's false? All right. That one's true. Now what's going on here is, again, this type coercion thing. Null and undefined are two different types, but remember I said they both represent something very similar. They both represent this concept of nothing. And so when you do a type coercive comparison, it does see them as equivalent. Whereas when you do one that's not type coercive with the triple equals, it doesn't. All right, now maybe you forgot what the values of them are, but what about food double equals bar? Who thinks it's true? A couple trues. Who thinks it's false? Who doesn't remember what the values of them are? All right, I think foo is undefined and bar is null. So if that's what they have right now, who thinks it's true? All right, who thinks it's false? It's true, because it's pretty much the same as here, except I flipped them around. It's undefined equals null. So now let's do foo triple equals bar. Who thinks that's true? That's false. Who thinks it's false? It's false, right? All right. For the most part, other than a couple little things, nothing too odd there, except for the one that I said we're going to come back to, right? The thing that makes no sense, type of bar is an object. Wait a minute. I said that null was a type, but when running type of null, returns that its type is object. I'll even show you that just if I did it directly. Type of null is object. What's going on? This is actually a bug in JavaScript itself. From the very beginning of the language, they made the mistake of letting type of null return object, even though it is a type. In the specification in the language, it's a type. This is just a bug that's existed in the language since the very beginning. And they can never take it out now because some programs have been written that rely on checking if null is an object and do something off of that logic. So if they ever changed the way it worked, those programs would break and people would have to rewrite those programs. They try with JavaScript to not break the language for people. So it's a very ugly little quirk that just has to stay in the language.
What should it be?
It should be null.
Just null.
Yeah, it should be null because it's its own type. Null is its own thing.
Is there another way to assign null to a variable other than just saying null? Like how did you with your other values that come out as null?
That's a good question. Is there another way to get null into a variable? I'm sure that there are some other ways to get null. Off the top of my head, yeah. Let me check something real fast. I don't know if this is going to give me null. It'll give me undefined. Let me try this. What am I gonna get? Nope, undefined. I don't know. I mean, it definitely happens a fair bit. So it's sort of weird that it shows up so much, even though you almost have to explicitly do it. So there's some ways, off the top of my head, I'm just not thinking of them, but there are definitely ways to end up with null in your variable, even when you didn't intentionally assign null into it.
But usually if you want something to say no.
If you want it to happen, yes. Usually, null is not something that you wanted to happen. Usually, null is an accident. Usually, it's, oh, this shouldn't have been in this state, but it ended up there anyways. It's not usually a state that you're intentionally putting stuff into. It sort of represents, I don't know, it said nothing. It represents like something's gone really wrong here, and I just have no idea what to put into this, right? Yes.
So then, what I guess example would be that software
I don't know. That's a tough one. You mean at least null being an object, like I mentioned here?
You said that it changed.
Yeah. What it is there's probably, the problem is there's, billions of lines of JavaScript code out there that people have written that's running on websites all over the place. And so somewhere someone has some logic that looks something like this, and it's intentional, where it's like if type of bar equals object. So it's checking if the type of bar returns the string object. Somewhere there's some logic around that where even though there is an object type in JavaScript, they've got some expectation that, like maybe they wrote it this way. And this is a little weird. I'm gonna show you something else first real fast. So undefined and null are falsy values. So if I did like not bar, I get true, or if I do the double not just to make it keep it with the same value, it's falsy. So it evaluates to false. And so both undefined and bar that way. So if I did the same thing with foo, you see the same. One shortcut that you'll see a lot of times in code is there may be some bit of code that just checks for undefined or var or any other falsy value by doing something like if not foo console.log falsy. And if it's undefined or null, it doesn't matter. It's going to be falsy in that case. So I wouldn't doubt that somebody has written some code somewhere that reads similar to this. Going back to what I just had, if type of bar equals object and not bar, which implies that it's no or falsy in some way, then do some logic. And that would be an example of some code that would break if they changed this to instead be explicitly like null, because they would have to change that. Yes?
So just to answer the question of like what's an example, one of the common things I do when I'm writing code is to like scrape data from web pages. And those, let's say I want to grab data like 100 data from 100 different stocks or something. Like, go to Yahoo Finance and like all those stocks will have like the same format. All the web pages like they'll list like revenue, the company, profit margin, all these kinds of things. It'll be like very standardized, and 99 will be perfect. And then one of those pages will have a bug in it, and it won't have kind of the web. I'm doing stuff in my code, I'm reading all these things, kind of like, say I want to like calculate something based on the revenue. If that revenue variable doesn't appear on the web page, that one web page that has a bug in it, then my code is gonna break because if it doesn't exist, the code will just throw an error and just stop running. So oftentimes what I'll do is just put in like a little like hash that says like if this is null, then print error message but continue running, don't stop. So that's a common use. That for me at least is when I use null.
No, I mean that's a good example. Yes, and it'll depend in JavaScript whether you get null or undefined based off of the way that data came back to you. Yeah.
So is another way of writing null is basically writing any falsy value?
No, I mean null is a keyword, so you'll notice it's like sort of bold there in this. It is its own value, and that's the way that you can really get to it, I guess. Just like undefined is, whereas like falsy itself doesn't exist. False does, but false is a Boolean value. The null is its own value and can just be typed plain on anywhere. Whereas a falsy value is just going to, it's a little hard to explain how it gets used, but essentially it basically becomes a Boolean, even though it doesn't always become a Boolean.
You had like a double equals after null, like null double equal. Any like let's say only the without anything. Does that return true?
No, if like we're checking against something that's truthy, it will return false. But if we check against anything falsy, then it should. Now, of course, it's going to be weird on me right now. Thanks. Oh, that's because again, I'm not doing this right. I have to actually evaluate this because truthy and falsy don't always happen that way. So let me try this. I think this will work. All right, JavaScript's a horrible language. No. Yeah, I don't know what's going on there. Honestly, I'd have to look at it a little bit. Welcome to the quirks of the language. So this is a fun little page I like. it's sort of comparing the difference between null versus, say, 0 or empty. Little programmer humor. Why is it getting smaller? It's saying like this is empty, or this is like 0. This is null. There's nothing there. It's not a real value. And unfortunately, I don't have my audio hooked up here. I would play one of my clips that I have there, which is just the clip from Charlie and the Chocolate Factory, where he tells him, "You get nothing." Nothing. Good day, sir. That's like what I think of when I think of null, right? You get nothing. Any questions? Other questions on null or undefined? All right. So this shouldn't take very long. We'll talk about block statements and when you would use them. But let's do another one of these. What do you think this bit of code is going to do when we run it? What is going to get output from it? What's that? Have a nice day. Any other guesses? All right, let's try it. How is the JavaScript class going? And have a nice day. Who's confused? Anyone? All right. The key here is that when you declare an if statement, if it's true, it will evaluate the next statement that it encounters. And if it's false, it won't evaluate that statement. In this case, this is the next statement. So it gets evaluated based off that if statement. It doesn't get run. But this statement is the statement after the next statement. So it's always going to get run. I intentionally indented this misleadingly because this is an easy mistake to make. The indentation doesn't matter. What matters is what is a statement and what isn't a statement. And that's where having the concept of a block statement is important, because a block statement is used to group 0 or more statements together. The block is delimited by a pair of curly braces, and it allows you to provide multiple statements where only one is expected. So it lets you group statements in that way. So if we took this same code and we made it work the way that we expected it to work for all of us, so we put these curly braces around this, now we've turned this into a block statement. So that's one statement to that if expression, and when we run it, neither one of those lines is going to run. Does that make sense? Working with block statements? All right. And we're disconnected again, I'm guessing. Got a bad connection here for the monitor. All right. So that's an easy mistake to make, which is one of the reasons that even though you don't have to always put curly braces after an if statement in JavaScript, you saw that there weren't any in this first version of this, that I recommend always using them so that that doesn't happen. Because one thing that'll be very frequent if you don't use curly braces is especially when you're working on a team, right? You're not gonna work, if you're a programmer, you're usually working with other programmers. So you write a bit of code and, oh yeah, I only have one simple statement. It's easy, I'll just put it here. It's clean without the curly braces, no problem. Somebody else comes along 2 months down the road, has to make a change, sees your if statement, says, oh, we need to do one other thing inside of there, adds their statement right after the one that's in there. And now the code's broken because they didn't realize that there wasn't a block statement there, and their code is running all the time, not just inside of the if statement, right? So using those curly braces, making an explicit block statement is sort of a safeguard to make sure that those sorts of accidents can't happen easily in your code. All right, so let's continue to build on this. And you guys have already talked a lot about this, so we'll probably go through this pretty quickly. But we're going to write this collectively. You guys can help guide me through it as I'm writing this. We're gonna do a little bit of code here using only what we've learned so far. Let's write a program that computes the total price of an item including tax. Tax is computed as following. If the category is food, the tax is 1%. If the category is clothing, the tax is 2%. And if the category is anything else, the tax is 5%. So I'll give us the starting point for this, where I'll say, I don't know, $4.95. Category equals food. And how are we going to write the rest of this bit of code? Yeah. I very well could. I think that's a good suggestion. So let's do food tax equals 0. Var clothing tax equals, and this is a little weird that way it's written, but this is I'm just going to multiply so it's easier to, what's that?
That's 20%.
Oh, thank you. And then we can do, one more. Var general tax equals 0.05. All right, what's our next step?
I think the next step is to remove the food tax. Because if you multiply by 0, you're gonna get the whole thing. So the food tax is null. Right?
Nah, I mean, you'll see the way that we write that. We could, but what's that? Start a block statement? I could. In this case, we're only. I'm going to make an assumption that I'm just going to hard code these and change these each time. So yes, very soon we'll start making those variables so that we can change those values more easily. Right now, I'm just hard coding them as my inputs. So I've got a block statement. All right. I want to do an if statement. What should I do here? If category food. All right. This video connection, very delicate here. I don't think it's up here that's the problem. I think it's farther down. All right. Maybe move a little less. All right. If category equals food, I'm going to add one more variable up here. I'm going to say total. Start it off at 0. That's just me giving a place where I can store the final value. Oh, maybe I don't need to store the final value. Maybe we'll just do it this way. All right, console.log. All right. Need another console log? What's that? An else? Oh, we haven't learned else. We will in just a moment for the people who. So let's run this right now, right? Let's give it a go. See what happens. Get back 0. That doesn't seem right. So there's something wrong. Anybody see what we're doing wrong here?
Multiply by 0.
Yeah?
Why did you choose to just run it right then?
Why did I choose to run it then? I partially was just cheating. I knew that there was something wrong, but also because since I'm hard coding the value of food and item price, I knew that, we're already going to run this if. Like if I change this, let's make this clothing, right? Then we know that we're not spitting something out right now. But essentially, I was choosing to run it because one of those best practices, and this may have been something you're priming for too, is try to run your code very frequently, right? Make tiny, tiny changes to your code and run it if you can. The more that you write, the more likely you are to have errors. If you make a tiny change, run it, tiny change, run it, you're much more likely to catch those errors early and know exactly where the problem is at. Whereas if you write a 50-line file and then you run it, you're gonna have a really hard time figuring out where you went wrong. All right, so we have a problem. Anyone got the answer? Yeah? Multiplied by 0? We have to add something here. So what you actually want to do is you want to do item price times the tax added to the actual price. That's how you calculate tax, or the total is you do the price of your item plus the item price times your tax. What's that? I do, yeah. You just can't see it right now. So I didn't need this total because we're not using it in this case. We'll get rid of it. Okay, so if this works for food, now let's do clothing. Yes?
If you did it all, I guess you would you go through all, or you have to do if they can't do this. The cost for the more together.
What do you? Well, that's I think sort of what we're getting at. Maybe. Let me see if this answers your question as we build on. So, all right, we need to be able to work for clothing. So, were you proposing a way for us to?
Usually before
Right. I'm going to go ahead and copy this. Right. Times clothing tax. All right. And let's test this. We get it, although, you know, you could quibble over whether we should be doing some sort of rounding on our cost here. Yes?
When you agree with item price, again, instead of just having item price plus, instead of this item price, can we just put 1 plus clothing tax?
Yeah, that's just not.
What-
He's saying just today's rules of putting item price times 1 times brackets 1 plus.
Yeah, you could. That's a totally viable way to do it as well. Yeah. Or you could even write them up here that way, where the values are 1, 1.02, and 1.05, and then you don't have to do the explicit second bit of the computation there. All of those are perfectly valid. All right, so we're working for clothing. Now let's have another category. And it's just another if statement, right? I'm doing this sort of intentionally. But, oh, this one's a little different. Because what were our rules? Our rules were if it's not clothing or food, we want to do our general tax. So our if statement here is wrong. Now, how do we change our if statement to match this last case? So this is the one that we want to have match for anything that's not clothing and not food. What? Yeah, so if category does not equal food and category does not equal clothing. All right, let's see. Looks like we worked, got a different value. So we've got this, right? And yeah, for the people who already know if and else, I'm being very explicit to show the benefits of doing some of this stuff. I've got the belief that once you've done stuff a harder way, it helps highlight why you want to write it a different way and the benefits that it gives you. So now we can introduce the concept of else. And else is an if statement has a second optional portion. It doesn't have to exist, which is the else statement. And the else statement is executed whenever the if statement evaluates to falsy. So if is false, it evaluates the else. So in this case, in this bit of code, for example, the math works as expected because 3 is not greater than 4. So it evaluates the else, right? So now let's go back to what we just wrote collectively, and let's maybe make it a little simpler. Can we make it simpler using an else statement as opposed to these 3 different if statements? All right, what do we got? What? Else. And I'm going to make this another block statement. Else. Okay, so if it's not food, what do we want to do? Is it all right? So let's test this and see. I'll get rid of these. I'll comment them out for the sake of just leaving them there for now. And we'll see. So we have sporting goods right now. Let's see what happened. Oops. Wrong command. We get what we expected. Okay. But what if we change the item we're buying to be clothing? What's going to happen? No, that's not right. It looks like he gave me the same price as I would have gotten for the general tax.
You want to do another if then that before the else.
Within this if statement?
Like, so if it's food, or you can just do it or like food or clothing.
You can do that. All right. Is that all I need? All right.
If you have a second, if else.
If else,
Yeah, so have a second.
I could do that potentially, although you can't put it in between the if and the else. But I could, for example, maybe this, there's nothing that says I can't put an if statement inside of this else. I've made it a block here, right? And so if we're not food, we're going to run into the else. So what could I put into the else to deal with my 2 conditions I have left? Not an else if. I'm inside of the else. Okay, an if here. I could, my next 1 condition, right, is clothing. I'm just going to go ahead and copy this line. Don't want the comments. Uncomment it. If you're wondering what I did there, by the way, if you work in an IDE, it doesn't work in all of them in coding environments, but a common shortcut if you want to comment or uncomment lines, not in everything, but just about everyone will have a shortcut, but frequently command and I can never remember which one's slash and backslash.
That's at the bottom backslash.
The one that backslash, I guess.
On your keyboard.
Oh, the slash is at the bottom.
Yeah.
So slash. Isn't that awful? I don't know what my keys are that I use all the time. So on a lot of IDEs, it'll be like command slash. If you hold that, it'll just comment the line that you're on. So it's a nice little keyboard shortcut. Okay, so now we've got this case. We still need to deal with something because this if works, but this is always going to be evaluated. We can do another else, right? All right. And in this case, look, we got rid of that ugly bit of logic that we had that said if not this and not this. So now in this case, it's a little more streamlined. And we've got the right logic for clothing. And if we check like sporting goods, we can see if we get the right tax. And if we check for food, we can check our tax. And they all look correct, yes.
So then if you were to do the variable, and put else, the next variable else, but if it's not like food, they'll just go down the line and say, oh, the clothing, and then okay, then I'll go down to, would you put it all together? Like would you put variable, if you would have basically put variables for food, clothing, and category, or general, right, and then you would also do those else statements, instead of having to hard change it every time.
You mean changing this category?
Yeah, if you variables, also put variables for else statements.
I mean, I could have, and we'll get to that code reuse. I could have put this into something like a function or into, say, a loop where I change some values outside of it, and then you can see what happens with each of them. We just haven't dealt with getting user input yet, because in JavaScript, unfortunately, outside of the browser, it's a little bit of a challenge to get user input. So you sort of need to build some other things up. I wish that there was a really streamlined way in Node to get user input so that we could have more dynamic code at the start of the class. But I find that trying to get that working is a challenge, more of a challenge than sticking with some of the static stuff at first and then getting input a little bit later. So people okay with the way that we wrote this if else? Pretty simple, right? Now there is one simplification we can make to this. I heard somebody saying else if, right? One simplification we can make, let me just check what I have here, make sure I'm not missing anything. Is we can write this like this instead. Let me just double check some stuff here. Get rid of this and change that indentation. And so this is the same logical code as what we just had. Oh, this is still indented too much, as is this. There we go. We have if, else, if, and else. One important thing, I mean, it's not that important, but it's a good thing to know, is else if is not a concept in and of itself. What's going on here is this is just an else statement, and it executes the next statement, which is this whole if block. So it's just a shorthand for what we wrote before. It's not a special, actual, different programming construct, right? We just got rid of our curly braces, and it let us make it look a little more streamlined, right? And now you could do this logic with, just about anything you want to do. Gives you a lot of options, a lot of capabilities. Any questions on this? Good? All right, we've gone a little long for the first half. I'm gonna throw up maybe just a couple-minute timer if people want to take a quick break. And then we'll get into, oh, I do have one more thing to cover before we do that, I guess. No, we'll just cover that in the second half, I guess. I want to give people a chance to take a break. So we'll take a couple-minute break if people want to, need to go to the restroom, want to get a drink or anything. And we'll be back. I'm going to throw a timer up real fast so people can see that. Of course, I touched the cable. How dare I? This thing is super finicky today. I think it's got it again. Give it stretch, right? It's getting late. Get tired. Especially if you're a morning person. I'm more of a morning person than a night person. So this is your chill time? Ah.
Stay awake.
I feel it. All right. It's okay if people are still strolling in and out. This next section is basically showing a, let me skip over for a second. And we'll do this like we've been doing some of our other ones, is here's a small bit of code. What do people think is going to be output when we run this small portion of code? What's that? Nothing? Nothing? All right. What else? Matt's looking at very intently and looking at me. What? All right, let's see what happens. What? Did anybody see the bug in this code? Boom. I did this intentionally because I will almost guarantee you're going to do it. This is a very, very common mistake. Assignment evaluates to truthy. It sees that as a truthy value and it runs that code. Right? It's assigning that into it. So now, if, for example, I console logged not the answer down below, it would be 42. So that's just one of those gotchas to be aware of. You're probably going to make that mistake at some point. Pay attention to it and try not to get too frustrated when it happens. So moving on to the last concept for today, let's talk about while loops. Now I know some of you have worked in other languages, so I'm sure you're familiar with how some of this works, but basically until now, all of our code has moved from top to bottom in our program, right? Even if we've skipped over some portions because of an if statement where we skip some chunk of code, all the code is just read very linearly, like you're reading a book. You might skip forward. But a while loop is the first thing we're going to introduce that allows your program to run a bit of code, not just linearly. It's going to be able to jump back up and rerun portions of code over and over. And that's really going to give you pretty much what I would say is, honestly, after we've got these if statements and these while loops, at that point, you've got all of the tools to write the vast majority of mathematical type programs, right? I'm not saying it gives you the GUI tools and everything else, but just about all of programming could be built with just this small set of primitives that we've introduced to that point. So while loop is pretty basic in terms of how it works. In this case, small bit of code here, we just assigning a variable, and then it's saying while, and go ahead and try and read this like English, right? It says, while count is less than 10, run whatever is inside of this, run this statement, because that's just a statement, but it's this block, right? And in this block, we log what the value of count is, and then we increment count so that it's one larger. And then what it's going to do when it hits the bottom here is it goes back to the top of this while loop, and it checks to see if this statement is still true. So in this case, if we're going to walk through it, right, count starts at 0, so 0 is less than 10, true. It prints that out, goes back to the top, and runs through it again, except now count is 1. 1 is less than 10, it prints it out, right? Any questions on that right now? So what do you think is going to get output by this program? See? You already caught that, right? I was going to say there's pretty much a bug here because I said we want to output 0 to 10, but we're not. What? Yeah. We can fix that by doing greater than or equal to, or less than or equal to, I mean, and then we get all the way up to 10 because it's going ahead and run through when it's at 10 as well, right? So you can do a lot of complex stuff with this. You can put if blocks inside of the while loops to really start combining these concepts. And that's some of the stuff that you guys are going to be doing on probably either this assignment or the next one. I don't know if I'm going to be able to get everything together for a good assignment out of tonight or not, or if I'll end up working more of it on Saturday for you guys to work through some stuff. But once you've got this set of constructs, you've got just about everything you need to write most programs. Now, mind you, there's a lot of nice things we can put on top of these to make it easier to write programs. That's pretty much what we're going over from here on out, is everything's tools that make it easier, because it would be really, really hard using just these tools to write something like Windows. And so we've got a lot of tools to help us manage the complexity of code and working with much more complex behavior. So let's go ahead and run another example here. And this one, since we just went over the other bit, hopefully you can maybe guess what's going to happen. But what's going to happen when we run this code? It tells you what? What's that? Remember, we just talked about how assignment is truthy, right? And so the assignment that we did here, we accidentally are doing an assignment inside of our while loop. And so every single time it evaluates to true, and it just keeps running, right? This is something you'll also probably do. Remember that Control-C is your friend. When you end up writing an infinite loop in your code, it's going to happen. And it's not going to be as obvious as that one was. Yours is going to be much more subtle. You're going to do something like this accidentally. You're going to say start count at 10 and say while count is greater than, you're going to say while count is less than like 100 or something, because you just accidentally put a value the wrong way. Count equals count plus 1. Let me see, I've got this wrong. Oh, let me do this. While count is like, it's like we're going to do a count down or something, or you intend to, while count is greater than 0. But, oh, I've got my logic wrong here, so I'm actually counting up instead. Like, that's the type of thing that's going to happen when you're coding, is you're going to make these mistakes, you're going to screw that up and not realize what's going on. So you're probably not going to have a console log. And it's even worse when you get into really complex programs later down the line, and it takes 3 minutes for it to run in the first place. And so you're like, all right, I guess I'll wait 3 minutes to see if it runs. And 5 minutes, you're like, maybe it's just slow right now. And in 10 minutes, you're like, no, I probably did something wrong. And now I've wasted 10 minutes of time trying to figure this out, right? These are useful things to be aware of because you're going to encounter them. And so I'm trying to emphasize some of that just so that you guys are sort of looking out for them ahead of time. So the last small thing I wanted to go over with while loops, and then your next homework assignment will definitely emphasize working with this and combining this with if statements to start building more complex programs, is how can you break out of a loop early? And this one's very contrived, but there might be other reasons to break out of a loop early. Maybe we can even come up with a better one. But in the bit of code we have here, and I really should be typing this stuff out instead of just copying it for you guys. But this bit of code is, let's go all the way up there. It's sort of another way to do this count program that we had. But it's relying on this break statement. So what we've written here is initialize count to 0. And then our while loop is an infinite while loop. It says run forever, or every time you hit the top of this while loop, run again. And then what we log is how many times we run so far, essentially. But what we've gotten here is a special thing that says if count is greater than 10, break out. And another bit of code that you haven't seen yet, which is this is a shorthand way. It's called the increment operator. But it's the same thing as typing count equals count plus 1. It's just a heck of a lot shorter and easier. So you know that programmers are lazy. And it's quite obvious by the fact that we've created increment, and we even have a decrement operator that does -1. Since we built those into our languages, we do this a lot, where we're just incrementing something over and over and doing a loop. It's such a common construct. We got so tired of writing it out that we made a special operator to just shorthand this logic for us. And this goes ahead and runs through here. And you'll notice the one difference in this case is it says count so far is 11, and that's because we don't break out until after we've already logged that case of 11, because we're looking if count is larger than 10, right? But that break is just another way to get out of a loop. And there might be other reasons to do that. Let's build another really contrived example here that's sort of the same thing, just doing something a little different. I'm going to start it at A. I'm going to change this a little bit. It's cheating too much to tell you what I'm trying to do. And here's another shorthand. This is, again, we're lazy as programmers. We hate typing stuff out if we don't have to. So we build stuff into our languages to make our life easier. This is the same as this. Now, let me use double quotes everywhere so that I'm not being weird. So these two statements are equivalent to each other. So unless there's a bug here, let's see. So that's just another use of using a break to get out of your logic here, right? Another really good example, what Matt was talking about earlier. This is the type of situation where maybe you have, and we'll talk about arrays in the next class, but maybe you have a list of items. And if one of those is different than the others, or something's wrong, or it's missing something that it needs, you don't want to continue running your code because the rest of your code is going to fail if it tries to run that. So you might have logic inside of a loop that breaks out in that case. They'll say, oh, break, because something's going to fail if I try to do this. So an example of that might be, let me change the order of some of this around. I'm going to move my console log down here. Again, another pretty contrived example I'm going to show you here, but where I'm going to say if say equals undefined, break out. And then I've changed it, so I'm not actually defining it up there. And I did that because if I don't have this bit of logic and say I was trying to, I don't know, do some other bit of code down here with say that isn't going to work, like maybe I'm going to change this and I explicitly had say equal to null. So if say equals null, I want to break. And now if I didn't have that, I actually don't know what's going to happen here, right? Let's see. And first it's going to keep running forever. But it concatenated the string null onto the letters A, which is, oh, that's not the behavior I wanted. I was wanting it to just start with A or something. So I wanted to safeguard myself from that bit of logic. And that might be a use where you would use a breaks as well to kick out of something so that you don't go into a case that's going to cause a problem. Yes? Oh, that's just because I had changed what the code was doing. I changed it from, move this back up. I just changed it so that instead of having a number here, I started with the string A. And then I'm going into the loop while true. So it's always going to be true. It's going to log saying and then whatever is in say, which in this case is just a string A. And remember, we introduced the concept in the homework of you can measure the length, how many characters are in a string using this dot length property. So then I just check if this say string has more than 10 characters in it, then break out of my loop. Otherwise, and let me make this the more explicit version this time so that it's easier to read. We just take whatever was in say and concatenate another A onto it, and then it goes back to the start of the loop. So I just changed the code on the fly so that we could show some similar examples, but just different enough to hopefully give some more context. Oh, in that last one? That's because I got rid of that logic. I changed it around again. I had it checking for null or something else. I wasn't checking the length anymore. So yeah, I'd sort of broken that logic intentionally. Yes.
You have a break there. You say length is greater than or less than 10 or 100. Would it still run until it got to 10 and then start going from 10 to 10?
If I said, what did I want to say? Oh, I said or.
Well, if you just switch and say that length is less than 10, that would just once it hits 11, would it hit 1 without the break?
If I took out the break?
Yes, once it hit 11.
Oh, yeah. You mean if I got rid of this? Yeah. So if I just got rid of this, for example, and left everything else here.
Well, no. If you put 10 like would once it gets to 11, like you wouldn't see anything until it got to 11, then at 11 when you start to see results. Remember you said earlier.
Okay. So there is something you can do that's like that. And I wasn't going to introduce it necessarily because you don't, usually if you're doing something like this, you're not using that. But there's another statement, there's another operator that's like break, and it's called continue. And so continue will skip the rest of the code in that running of the while loop and go back to the top. So let's say we change some of this logic around a little bit, and then we'll be able to do sort of what you're asking. Is I'm going to move this, I'm going to start this off with nothing in here. I'm going to move this assignment operation up to the top here, and then I'm going to move the log to the bottom. So it's going to log after it's put something in there. And first I'll leave this logic the same. And what we should see is it's pretty much the same, except I think we'll get one less, you know, A. We won't get the 11 version printed out. We'll just get up to 10. But now if we wanted to flip that logic, you could. And mind you, we'll end up with an infinite loop because of the way it's written. But if we want to use the continue statement instead, we could change this to say, if say.length is less than 10, then continue. And what it's going to do is skip over the rest of the code in this while loop and go back to the top and start running it from the top again.
Might be more effective.
So it skips that one.
Yeah.
I'm going to put the other one back in. Yeah, I like that. So here's what I'm going to do. I'm going to change it back over to be numbers because I think it's easier to do. It's easier to see what I'm talking about. So if count equals 0, count plus plus, I'm going to say if count is equal to 3. Oh, I'm going to give you guys a fun programming assignment now. I might have you guys use this continue. I might give you guys FizzBuzz. Oh, have fun. So then we're going to continue. Otherwise, we're going to say what the count is. And I'm going to add in one other bit of logic here to make sure that this isn't an infinite loop, which I'm going to put my break back in. If count is greater than 10, let's break. What's going to happen in this case is we count out the numbers except for 3. And that's because when we hit 3, it looked at this if block, said, oh, count is equal to 3, continue. And what that does is skip everything else in this while block and jumps back up to the top. So we never actually print in that case. Is that close to what you were asking? Yeah. So once we have that, and I wasn't even going to introduce continue necessarily, now you can build some really complex bits of logic. Like we could say only print the even numbers from 1 to 100 in some way, right? And you can do that a different way too. There's a lot of ways to do that, but there's the possibility to do that here. So, any other questions on this? That was good. I like that. All right. If there's no other questions, then we're going to be. Yep. Oh no, it's gone as fast as you got it. All right. Then we'll be wrapping up class for tonight. If anybody has any questions or wants to, more clarification on stuff, we can talk through some of that as well. I'll hang around afterwards if people have any questions or want any hands-on help with some of the work.